October 2021, Unit 1, Chemistry. Question 1. The maximum permitted concentration of sulfur in diesel is 10 milligrams of sulfur in 1 kg diesel. What is the concentration of sulfur in ppm? So concentration in parts per million will be equals to the amount of sulfur that is allowed times a million divided by the volume of diesel that contains this sulfur, which in our case is 1 kilogram. We convert it to milligrams. This and this will definitely go, so we remain with our answer as 10 ppm, 10 parts per million. Question B. 3.3 kilograms of diesel fuel is burnt. What is the maximum volume in dm cubed of sulfur dioxide which can be produced, measured at room temperature and pressure? Now, first things first, let's find out the amount of sulfur in 3.2 kilograms of diesel. So we know that 1 kilogram of diesel contains 10 milligrams. This would mean that 3.2 kilograms of diesel would contain 32 milligrams of sulfur. Now from here, we need to calculate the number of moles of sulfur that we have in 32 milligrams. But before we do that, we need to do conversions. We know that 1 kilogram is equals to 1,000 milligrams. Therefore, 32 milligrams converted to grams will give us 0.032 grams. Now, number of moles of sulfur will be mass over relative atomic mass, which is 32. That will give us 0.001 moles. We write the equation of reaction between oxygen and sulfur to give us sulfur dioxide. Look at the mole ratio, and you realize that the mole ratio is 1:1. Therefore, the number of moles of sulfur dioxide will be 0.01 moles. We know that 1 mole of a gas can occupy 24 dm cubed. Now what about 0.001 mole? It will be 0.01 times 24 divided by 1, and this will give us 0.024 dm cubed. Therefore, our answer is going to be A. Question 2. Which equation represents the second ionization energy of chlorine? During ionization, the atoms should be in gaseous state. That is number 1. Number 2, since we're dealing with the second ionization energy, we need to pick an ion that has already undergone the first ionization energy. So in our case here, it is going to be D. Next question. The diagram shows a mass spectrometer. Which process occurs in the region R? Region R, we have electrons are removed from the molecules or atoms, and positive ions are formed. This is where collision of atoms and the electrons occurs, what we call ionization chamber. Which statement is correct for region T? Region T, this is where ions with a greater mass have a smaller deflection. Region T has a magnetic field which helps with the process of deflection of ions. Question 4. Mass of 0.23 grams of sodium was added to 350 cubic centimeters of water to form hydrogen and a solution of sodium hydroxide. As the equation shows, what is the concentration in mole per dm cubed of sodium hydroxide in the solution? So first of all, find the number of moles of sodium present. That is step number 1, which is mass divided by relative atomic mass. We get 0.01 moles. Now using mole ratio, sodium and sodium hydroxide, the mole ratio is 1:1. That means the number of moles of sodium hydroxide formed will be 0.01. Now, from there, let's find out if 350 cubic centimeters has 0.01 moles of sodium hydroxide, then what about 1,000 cubic centimeters? The reason why we are doing this, we know that 1 dm cubed is equals to 1,000 cubic centimeters. Therefore, 1,000 times 0.01 divided by 350 cubic centimeters, that will give us 0.029 moles per dm cubed. Our answer is B. Question B. What is the maximum volume in cubic centimeters of hydrogen which can be formed measured at RTP? So again, using the mole ratio now of sodium ratio hydrogen. The mole ratio is 1:0.5. That means the number of moles of hydrogen will be 0.01 times 0.5 divided by 1. This will give us 0.005. Now we know that 1 mole of a gas will occupy 24 dm cubed. What about 0.05? It will be 0.05 times 24 divided by 1. This should give us 0.12 dm cubed. But the question is very specific. We need to give our answer in cubic centimeters, so we multiply by 1,000. That gives us 120 cubic centimeters. Our answer is A. Question C. Sodium hydroxide solution was neutralized with sulfuric acid. What is the ionic equation? The ionic equation is hydrogen ions plus hydroxyl ions will give us water. For all the acids that we are going to deal with, there is one constant, and in all these, the constant is the hydrogen ions. Question D. Sodium hydroxide solution was added to magnesium sulfate solution. The equation for the reaction is shown. What is the atom economy for production of magnesium hydroxide? Atom economy is equals to relative formula mass of desired product divided by the relative molecular mass of all products. So in that case, we have 58.3 divided by 142.1 plus 58.3 times 100. That should give us 29.09, approximated to 29.1. So our answer is A. Question 5. in each series are the ions in order of decreasing ionic radius. So decreasing from the largest to the smallest. For A, aluminium has a smaller ionic radius compared to magnesium and sodium, so in this case it is increasing. Lithium compared to sodium ions and potassium ions, that is increasing. In this case we have increasing ionic radius, IR. Nitrogen, oxygen, this becomes our answer because we can see there is a decrease in ionic radius. If we look at nitrogen taking up 3 extra electrons, you increase the shielding effect. Definitely the ionic radius will be bigger than that of oxygen, which has only taken 2, and definitely bigger than that of fluorine, which has taken only 1. Then finally, if you look at the last one, oxygen, sulfur, down group 6, we need to know that as you go down the group, there is an increase in the ionic radius and the atomic radius. So our answer is C. Question 6, a stable ion contains 18 electrons. In which block of the periodic table is M found in? So we are going to take 18 plus 3. It's going to give us 21. Using the periodic table, if you check with the blocks that we have. Question 7, ammonium 2 sulfate is a double salt that is used as a source of ion 2 ions. What is the relative formula mass of the double salt? So for this one, what you do is just write down the elements that are forming the compound. You can choose to spread them out, then slowly by slowly, now account for each and every element. So in this case, nitrogen, we have 1 times 2 because of the bracket. Hydrogen, we have 4 times 2 because of the bracket. We have only 1 of ion. Sulfur, we have 2 because of the bracket, so that becomes 32.1 times 2. Oxygen, we have, for the first part of oxygen that is attached to sulfate, we have 4, but because of the bracket we have another 2. Hydrogen, that is in water, we have 12 because it is 6 times 2. Then oxygen, that is forming water, we have 16 times 6. So this will give us 28 plus 8 plus 55.8 plus 64.2 plus 128 plus 12 plus 96. So adding all those should give us 392. So our answer is 392, that is C. Ammonium sulfate is used in the preparation of the double salt. What type of bonds are present in ammonium sulfate? Ammonium sulfate is made up of 2 parts, the cation part and an ion part negative. So this part we have covalent and dative covalent. Between the two we have an ionic interaction. So we can say our answer is D because we have ionic, covalent and dative covalent. Question C, what is the total number of ions present in 0.01 mole of the double salt? We know that number of ions, particles, atoms is obtained by multiplying Avogadro's constant times the number of moles. In our case, we need to refresh and look at the double salt. How many ions do we have? You'll realize that we have, that is ion number 1, ion number 2, and ion number 3. So in total, we have 2 ions, 1 ion, 2 ions. So we have 5 ions in total. So answer is going to be 0.1 times the Avogadro's constant times the total number of ions present in the molecule. So that should give us our answer as 3.01 times 10 raised to power 23. Question 8. In which series are the elements in order of increasing melting point? For the first one, we are dealing with group 7. And for group 7, we need to know that the melting point increases down the group. In this case, we are moving up the group, so it will not be correct. If we look at B, lithium, beryllium, boron, carbon, we can see for this one we have increasing melting point. C is not our answer because as you move down group 1, you have a decrease in the melting point. For D, silicon has a higher melting point compared to phosphorus, sulfur, and chlorine. Therefore, that cannot be our answer. So our answer is B. Question 9. Which row gives the correct polarity of sulfur bond and sulfur 6 fluoride, which is a molecule? Now in this case, sulfur bonded to fluorine forms what we call a polar bond. But the molecule of sulfur 6 fluoride is symmetrical, so the polarities will cancel out, giving us our answer as B. Finally, not finally, but almost finally, methane reacts with excess chlorine in UV light. Which process occurs in the initiation stage? In the initiation stage, we have formation of the free radical, and a free radical is a species which contains unpaired electrons. So in our case, we need to remember two things. For initiation stage, we use half arrows to indicate movement of a single electron. So that rules out C. Electrons move from the bond to the element, so that also rules out D. A is being ruled out also because it's using a full arrow instead of half arrow, and it's only moving towards one direction. So our answer is B. Usually we have initiation stage, we have propagation, then finally we have what we call the termination step. Initiation step, you form the free radical, and this is with the help of the UV light. Propagation stage, the free radical that was formed in the initiation stage will form other free radicals, propagating, increasing. Then termination stage, this is where you have two free radicals joining up. It's like we can term it as cancelling out. So the next question is, what is which of these molecules could not be formed in the termination stage. So in this case, we have this cannot be formed. There are three reactions that we'll expect in termination stage. One is this, to form chlorine. Two, we have this free radical joining with this free radical to give you this. Then we have this joining with this to give you. So these are the products that we expect from the termination stage. You can see two free radicals. We can use the term cancelling out to make it easier for us to understand. Question 11. This is about geometric isomerism. What is the skeletal formula for E2-chlorobut2ene? Our answer here will be A. So just to show how we came by that answer, chlorine, this is a methyl, this is hydrogen, and this is a methyl. Now we need to rank the atoms connected to the carbon that is forming the double bond, the carbons that are forming the double bonds. So for these rankings, we look at the atomic number. So for the first one, we start to the left side. Hydrogen has atomic number 1 and carbon has atomic number 6. So in this case, when we are doing our ranking, it would mean that carbon is of a higher rank and hydrogen is of a lower rank. We move to the next side, which is the right side. Now chlorine has atomic number 17 and carbon has atomic number 6. So if we are to rank the two, we'll clearly see that chlorine is of a higher rank compared to carbon. So in this case, we have what we call entgegen. The molecules or the atoms with high rank are on opposite sides. E in German is entgegen, opposite. So for us to remember, we can say E is opposite. So that gives us E2-chlorobut2ene. We can compare that to what we have in the next question. So for it to be zusammen, it means the high-ranking molecules on the right, or high-ranking atoms on the right and high-ranking atoms on the left should be on the same side. So in this case, we have chlorine and methyl being on the same side. This is Z, zusammen, all together. Now let's count the number of sigma bonds present. So in this case, we have 1, we have 2, we have 3, we have 4, we have 5. So we have 5 plus here we have 3 sigma bonds and here we have 3 sigma bonds also. So that gives us a total of